Hopefully a short video. Someone asked a question in a YouTube video stating that when he looked up the subject he couldn't find any information on this, and I've had the same result, so we can all just make opinions. I don't have anything to back this up except this is probably how it happened. As a bullet clears the muzzle, it clears an area that's called the crown. I'll be getting to that in a minute. Upon releasing from the bore of a barrel, it releases upwards of 10,000 psi or whatever pressure suddenly, normally. This is back pressure. Now in front of it is a different atmospheric pressure, which must be as uniform as possible in the way it exits. Now I want you to think of everything else except a gun that is supposed to produce a reliable, controllable emission of accelerated gases. Remember, the pressure in a gun can just literally be a pop where the air stops moving rather quickly afterwards. I mean, it might not go on and on. It's not like a rocket engine. What else creates a sudden push forward? Sound waves. You're dealing with something that's transitioning from one medium to another, because inside the barrel it's a pressurized gas. It has a different PSI rating, different speed of sound, and it goes to now a different medium. This creates a sudden change in the medium it's exposed to. Now, depending on the bullet being a boat tail or whatever, or being a round ball, it's going to have one thing consistent. Every part of the exit has to be as consistent as possible. Now, if it's coming out of a rifled barrel, by definition, because the rifling creates up and down waves, usually square waves, on the exit of the barrel, this is going to create an uneven distribution of pressure changes. But it will also create enough of a pressure changeover that won't be too sudden, because the places where there are grooves will release pressure slightly before the ones that are not. And if they're made very even, the back of the bullet will not deviate much, or at all. Now remember, this may or may not really affect things in grand scheme of things, but it might majorly affect things. Please also see that if you fire a shotgun shell out of a gun that's rifled, because you can get a 50 caliber cartridge that's literally a tiny shotgun shell, you'll see a pattern form because the rifling affects things. We'll talk about the infamous 11-degree crown. Okay. The crown refers to the end of the barrel that's machined as a concave angle. The outside edge of the barrel is further out than the inside. So instead of an outie on it, you get an innie. That means the flush layer on the outside is different. A lot like the horn you might have tried to play in high school. The infamous 11-degree angle or whatever. Well, let's go on with this. This may be sharp at the bore or have a 45 chamfer, but the entire surface of the barrel is more emphasized as being the important part. The pressure release happens right at that edge of the interior caliber bore diameter. Doesn't matter how thick the barrel is, but the angle it's bent in at or cut in at is usually considered fairly important. Now, I'm saying usually because I'm going to go for this. The Wikipedia article and a lot of other pages also say the reason it's done that way has nothing really to do with accurizing a barrel. It has to do with the fact that makes it to where it's really hard for the end of the barrel to get damaged. The outside edge can be damaged, but that edge right at the bore can't. So that angle may have started as simply a way to make sure the barrel couldn't physically be damaged at the part that's important. You can scrape the outside of a barrel. You can do all sorts of stupid things to a barrel, like picking any rails on it, or putting My Little Ponies on them, as long as you blow a hole through them. But right at that tiny transition point between where there is and then there is not a barrel, it's important. But does that horn-like shape make a difference? Well, here we go. The contour of a muzzle, this, is designed to keep the rifle safe from damage by any foreign object. The front ends of the rifle and grooves are commonly protected behind a concave space called the crown. So that's the first purpose of it that is listed by most people, because that's the most obvious one. But when you do this accurizing and chamfering and yada yada yada, it does actually improve the consistency of the impacts for bullets. Although I would say that having bullets that are completely mechanically consistent, well made, and not complete shit are more important sometimes. This also serves to modulate the even expansion of the propellant gases. around the bullet as it comes out. And I'm going to bring up another thing. The crown itself is often recessed from the outside rim to avoid accidental damage, etc., collision surrounding environment. This is the second time it's said in the same Wikipedia article. Now, here we go. The 11-degree mythos. The front end of the barrel from which the projectile will exit is the last thing that touches the bullet. It has to not manipulate the bullet at all. The whole point of a long barrel is to give it a long distance to have inertia to keep going in the straight line, and also a large space behind the bullet to expand the gases and get as much energy transferred to it efficiently. It's the last point of contact, and machining it has to be precise. Now I'm going to go into a completely unrelated article. An acoustic horn or wave guide is a tapered guide designed to provide an acoustic impedance match between the sound source's air pressures and the free air outside of the horn. It's not just a funnel. We put the fun in funnel. This has the effect of maximizing the efficiency with which the sound waves from a particular source are transferred to the air. Pressure changes at the speed of sound, literally. Next, can be used at the receiving end as well to act as a receiver, because it's optimized for the impedance matching of the air down to whatever diameter you need here. See also this thing. It doesn't amplify it, it just makes it to where it doesn't waste energy. And because it causes an impedance or resistance or pushback transitional effect, widening out. It doesn't matter if it's even a tiny amount or a big one. This has the effect of making it to where it efficiently transfers pressure. Now, in the case of a gun being fired, it's not going to efficiently transfer any real energy increase, but it might make it to where it doesn't have such an extreme change. This allows for the pressure levels to fall off in a geometrically even distribution around the bullet, or prevent outside air from affecting it right as it's leaving the muzzle. Okay, now I'm going to get to my point. The angle may not matter, but it obviously, in my opinion, does. What happened, here's how it happened. 7.5 minutes in. The real cause of these things happening is people sat there and ground different angles and saw what they did. They don't know why it works. 11-degree angle, it means that if this is the flat barrel end, if you tilt it up 11 degrees relative to the inside of it, that will give you better accuracy. And they found out at one point or another that doing more or less of that may or may not give you an advantage. That seemed to be the least amount of material to remove from a barrel, the least amount of work to do, the least amount of wear and tear on the drill or mill or whatever, and allowed you to have an increase without a bunch of loss of time and energy on your part messing with it for 6 hours and maybe screwing it up or maybe wasting material that may have been precious at the time. Next, doing the least amount of changes to the barrel after you've made it means that you've done an extra step that you can do quickly and easily. Many barrels are just flat off. And I mean, they just have them flattened off in the end. Also because they're not deliberately making this curve, either if it's a curved shape or just a flat angle, they don't make it to where it will prevent it from shooting wrong, left or right, up and down. Now, the other thing is, people who accurize guns, there's a whole article on Wikipedia that's actually good, accurizing for a gun. And it can apply to all sorts of other things, but for guns, we're going to do that. When you look it up, you find out hundreds of things you can do to do this, including, obviously, changing the ammunition. I just thought I'd bring this up. But it's not some magic angle, it's just what they ended up finding out that worked. It may have also been based on whatever tool they had, like a drill bit. Thanks for watching, have a good day.